Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, today in this session we are going to learn a machine learning algorithm which is known as a K nearest neighbor algorithm. K nearest neighbor algorithm. So as far as simplicity is concerned, this is the easiest and the simplest algorithm to implement from the implementation point of view and from the understanding point of view. Sound low? Hello? Hello? Is there any issue with the audio? Panto? Is there any issue with the audio? Am I not properly audible? Good now. Okay. Thank you. Thank you very much. So, K nearest neighbor algorithm is the easiest and simplest algorithm from in the machine learning. So, let's discuss. And first of all, yesterday we were supposed to discuss the logistic regression, right? But for some reason I could not conduct that session, but don't worry. This algorithm is not related on that particular concept, so we will be able to understand this algorithm, and as and when possible I'll conduct the session for that particular algorithm also, that is logistic regression. Clear? Okay, so this is brief introduction of myself. My name is Vishal Rawatiya. I have 10+ years of teaching experience. Following are the achievements and areas of expertise. This is the Telegram group which you people can join. If you have any doubt related to GATE preparation, you can ask me at this particular group. Okay, this is a information. Rakesh Talreja sir is going to conduct a workshop on 4th of October at 7:30 p.m. In this workshop, sir is going to discuss the 7 prime qualities of a topper. So you can analyze and you can work on those qualities, and you can also be in the list of GATE 2024 toppers. So to join this workshop, this is absolutely free. You just need to register on the application. You just need to install the application and need to register using your mobile number. Right? This is the screenshot from the BYJU'S exam prep test series. You should also be appearing for the test series at the regular basis, because this is something which will help you understand the time management. It will help you improve your time management. Now, for all this, you just need the BYJU'S application. For the purpose of downloading the application, you can use the link available in the description. So the link is available in the description. You can use that. You can simply register and you can avail all the facilities. Okay guys, let's start with the K nearest neighbor algorithm, which is also known as KNN, K nearest neighbor algorithm. So please try to understand. Again, as I said, it is the simplest machine learning algorithm, and it falls under the category supervised learning. So in this particular series, we are only discussing these supervised learning algorithms. So whatever algorithms I have discussed till date are supervised. When I discuss unsupervised algorithm, I'll let you know. Okay, so this is supervised algorithm. Now, this K nearest neighbor algorithm can be used for the regression problem as well as classification problem. We already have discussed the regression problem, classification problem. What will happen in the classification problem? Given the input, you will try to classify your data into one of the possible outputs, right? One of the possible outputs means in regression, there will be continuous variable. Output will be a continuous variable. It can take any value. But in classification problem, your output will be one of the classes which are predefined, right? So anyway, we will understand the classification problem also. But mostly this algorithm is used for classification problem. You can also use it for regression, but generally it is defined or used for classification problem. Okay. When I say KNN, that is K nearest neighbor, is a non-parametric algorithm. What do I mean by non-parametric algorithm? It means it does not take any assumption on the data that what type of data should be given as an input to this particular algorithm. So for some algorithm, it will be an assumption that the data is normally distributed, or the distribution of the data is Gaussian distribution. But when we talk about KNN algorithm, then we can give any type of data to this particular algorithm. Clear? Apart from that, this KNN algorithm is also known as lazy learner algorithm. Please, 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 there are certain things. What's the objective? Whatever algorithm which we have discussed till date are the algorithms in which we will give the training data. Your model will try to learn from the training data. Your model will try to learn from the training data. It means the model will learn at the training itself. The model will learn at the training time itself. So model will learn from the training data, and whenever a new input is given to that particular model, based on its learning, it will produce the output, that what will be the output for this new input. But when I say it is a lazy learner, then what do I mean by lazy learner? The meaning of the lazy learner is that when you are providing the training data, it will not perform, it will not learn anything from the training data. It will not learn anything from the training data. It will simply store the data. And when you give a new input to this particular algorithm, then it will start processing. So it will learn, it will try to learn from the data which is available with the algorithm when a new input is given to this algorithm. So it's very lazy in the learning. Logistic regression is completed. No, Akhil, I just told that for some reason we could not complete the logistic regression session yesterday, but anyway, this particular thing is not dependent on logistic regression. It's just a classification problem. We will be able to understand it without any knowledge of logistic regression. Clear? Tushar, you are also facing the similar problems. Sound is low. Please let me check for once if there is any. No, from here sound is okay. Maybe some other problem. I'll check at the later point of time, but for me, I cannot do anything as of now, because whatever metric is available with me, all the connections are proper. Is it, I mean, are you guys facing any difficulty in understanding something because of this low sound, or it's just that you are facing some difficulty while trying to listen to me? If you are not able to listen to me at all, then we will have to do something else. But if you are able to tolerate this sound for a day or for this particular session, it will be great. Right? So anyway, so it's a lazy learner algorithm because it does not learn from the training set immediately. Instead, it just stores the data set, and at the time of classification, it performs an action on the data set. Whenever you need to perform, whenever you need to classify a new input, it will perform the action whatever is required. Now, KN algorithm at the training phase just store the data set. When it gets the new data, then it applies. Similar. So what's the idea? When I say K nearest neighbor, then it will eventually try to classify the data into the category that is much similar to the new data. So already you have categorized the old training data. Now, from whenever you provide a new data to this particular algorithm, it will do something that we will understand in a while, that what will be done by this particular algorithm. It will do something, and then it will select the group corresponding to which the new data is showing the maximum similarity, and that particular data will start belonging to that particular class. Okay. Anyway, so that's one thing. So let's try to understand the KNN algorithm with respect to classification. So this K is our value. This K is our value which we are going to discuss now. Right. So in order to predict the output Y for a new observation X, so first of all, the idea is that some of the observations will already be available to your model. And please, this algorithm is very easy, but the only problem is that people do not understand that what X and Y axes are representing in this particular case. Right? So, if I say that this is your X1, and if I say that this is your X2, and if I define a point here, if I define a point here, then what does it mean? What does it mean? What is actually happening in this particular case? What is actually happening in this particular case? Does it say that when the value of x1, the value of x2 will be this much? Is it what is being predicted by this particular model? No. So please try to understand x1 and x2 both are your input variables. Both are your input variables. Please try to understand what is happening here. Right? So in a simple linear regression, we learned that there will be only one independent variable x and there will be one dependent variable y, right? And then we said that if it is a multi-linear regression, then there may be multiple independent variables. There may be multiple independent variables. Let me call it S1 is one independent variable, X2 is another independent variable, X3 is another independent variable, and on those independent variable your value of y will depend. But when we are talking about classification problem, this value y will eventually define the class. Let's try to understand. Let me try to summarize this with respect to two variables. Let's assume that if the value of x1 is some a value of x2 is some b value, then the input will belong to yellow color class. Just the classification can be anything. Then if x1 is a, x2 is b, then it will belong to yellow color class, right? So if I say that this point is nothing but a comma b, then this will belong to yellow color class. Whatever the values of x1 and x2 are, there will be some values of your independent variables, right? So that's what will happen. Similarly, it says if the value of x1 is whatever, let's assume p, and the value of x2 is q, value of x1 is p, value of x2 is q, then it says that it will belong to red color class. So let's try to understand that if I give a point that this value is, let's assume p, this value is, let's assume q, then this will be your point p cross q. This will be your point p cross q, and this point p cross q will belong to red color class. That's what is being defined here. Don't think that with respect to x1 we are trying to predict the value. With respect to x1 we are trying to predict the value of x2. This is not happening. These are the two variables. Of your input. These are the independent variables of your input. Based on the values of independent variable, your class is being defined. That this is of yellow color class, this is of red color class. So that is what is happening. Is it clear now? So don't think that this x1 and x2 are eventually x1 is independent and x2 is dependent. Don't think of this particular diagram in this particular manner. Clear? So there may be various yellow color input. So these are the classifications. So please, we know this is the training data. We know about this training data that okay, when x1 value is this much, x2 value is this much, the class is yellow color class. x1 value is this much, x2 value is this much, the class is yellow color class. Here also we know the value, here also we know the value. So we know the classes also. So this is, what are you saying, Panto? What class? Species. Yeah. So basically it's a species because you have read the example of dog and cat. I understand that you guys are reading from various places. You guys are trying to learn from different sources. So I understand. It's absolutely fine. Right? So this are your red color observations. Right? So this is the thing. Now let's try to understand. If I give you a new point, what is this algorithm? So if I give a new point that this is my, let's assume, yeah, this is my new input. new input means it is my test data. It is my test data. I don't know that what class this particular input will belong to. I don't know that what class this particular input will belong to. So in order to identify the class, we may run this k nearest neighbor algorithm. What will happen? Sir, we'll try to find out the k nearest neighbor to this new point. We'll try to find out the k nearest neighbor to this particular new point. So what will happen? Let's try to understand the value of k. So we just need to identify the value of k. So let k equals to 3. Let k is equals to 3. K may be any value. This is another problem, that how do we identify the value of k, or what value of k should be used. Right. So let's assume that when we try to identify the 3 nearest neighbor, what information we get is that, okay, this is one of the nearest neighbor, this is another nearest neighbor, and let's assume the third nearest neighbor is this red color neighbor. So these are the 3 nearest neighbor. Then we will eventually try to find out that to which particular class the maximum of this k neighbors are belonging. Getting the idea? To which particular class the maximum among this k neighbors are belonging. If the maximum neighbors are belonging to red color class, then this particular new data item will be classified as red color item. Right? If the maximum of the neighbors are belonging to yellow color class, then this particular new item will be classified as a member of yellow class. Clear? Got the idea? What do I mean by k nearest neighbor algorithm? The value of k will eventually be of some use, but at this point of time, the basic purpose is clear, that what will happen because of k nearest neighbor algorithm from the classification point of view. Right? So please, I don't have sufficient space. I will have to remove this. I have explained the concept. You can take a screenshot of this particular thing. So you can just say that neighbor, one neighbor, let me use the color. Let k equals to 3, and we identified that one neighbor from yellow color class. And 2 neighbors from red color class. Red class. So maximum are from the red class. Therefore, new input is classified as a member of red class. This values may be anything. Clear? So that's what we will do. That we will have a random value of k. We will choose it so that the output is correct or the accuracy is maximized. But as of now, please try to understand the algorithm, that what is actually happening. Right? No. Low. So please try to understand that this x1 and x2 are your inputs. They are not defined, they are not predicting anything related to output. For the prediction purpose, we will have to do something else. So please let me explain in the form of points. So first of all, what are we trying to do? Given a new observation x, we will do what? Given a new observation x, we will eventually try to identify the distance of this new observation from all the data sets, from all the data available in the So sir, every new input will fall in red class. No, 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 no. How? Every whatever the value of x1 and x2, whatever the value of x1 and x2 will eventually try to identify the distance. Will eventually try to identify the distance of that new point from every other member. It will be clear when I specify this complete algorithm here. So please try to understand. What in order to predict the output of y, output y, in order to predict the output y for a new observation x, what will we do? What will we do? So first thing is, the very first thing, find the distance, find the distance of new observation x, new observation x from all the data, from all the data points available as training data. From all the data points available as training data. Now what? Sir, that's the worrisome thing. If there are 100 points or if there are 1 lakh observations in the data set, then for a new input, you will have to calculate the distance of that new input from all those 1 lakh points. Getting the problem? It is easy to implement. Okay, easy, but it does not mean that it will be efficient also. Clear? So if there are already 1 lakh data points in the data set, and if a new point comes and if you want to classify that to which particular class this element will belong to, then first of all we need to identify the distance of this new point from all those 1 lakh data points, and it will be time consuming. Clear? So find the distance of the new observation x from all the data points available as the training data. Now the second thing which you will do is that we will list the distance in the increasing order. We'll list the distance in the increasing order. Second thing is sort the distance in non-decreasing order, if I say so. Two distance may be equal, therefore let's say sort the distance in non-decreasing order. Then third point, so let's say assume that the distance of one point is 1 meter, distance of another point is 1.5 meter, the distance of another point is 2 meter, distance of another point is 2.5 meter, distance of another point is 3 meter, distance of another point is 3.2 meter, distance of another point is 3.5 meter. Let's assume the value of k is 3. Let's assume the value of k is 3. Then choose the top 3 points, which are closest to this new data point. Choose the top. If the value of k is 3, then basically if the value of k is anything, then choose the top k points which are closest to this new observation x. Got the idea? Sir, can we say classify? Yeah, we can say so. Classifying training data. Right, so the next thing is this, that we will arrange all the distances in the non-increasing order. Then what? Third point is choose top k points from that list which are closest to the new observation x. That's it. So now you know that. Then check that maximum likelihood. So now you need to do is, the last thing which you need to do is fourth point. check maximum among those k data check maximum among those k nearest neighbor. So closest means nearest. Check maximum among those k nearest neighbor belongs to which class? Belongs to which class? The new input will also, the new input x will also belong to same class. Got the idea? Simple algorithm. Simple algorithm. Got the idea? But the only difference, only problem here is that how this distance is calculated. Find the distance. Find the distance of this new observation x from all other data points available in the training set. So there are two types of distance which we consider while implementing k nearest neighbor algorithm. One is the Euclidean distance. We all know how do we calculate the Euclidean distance between 2 points. Another is Manhattan distance, right? Anyway, but this is not that big of a problem that what is Euclidean distance or what is Manhattan distance. The problem, I hope the problem is clear, that whenever I want to classify something, then I choose a value k, whatever the value k. We'll discuss about that k value at the later point of time. We'll discuss about that k value at the later point of time. But the thing is that if you want to check that a new input will be classified or will eventually belong to which class, then you just need to check that you just need to check the distance of that new point from all the existing point in the data set. Then select k closest point to this new point and check that maximum among those k data points belongs to which particular class. Now, whichever class the maximum neighbors will belong to, this particular new element will also be a member of the same class. Clear? Clear? Normal observation. So this is the classification problem. This is a classification problem. Clear? Let's look at the regression problem. If the classification is simple. Now, how do we check the regression problem? Please. Regression problem. In regression problem, what you need to do? In regression problem, you will get a continuous variable, a real number or a continuous variable that can be any value. So please try to understand. Please try to understand that again we are doing the same thing. X1, X2, whatever. Let's take only two variables. Let's take only two independent variables. So these are your independent variables and this y is your dependent variable. This y is your dependent variable. And this can take any real value. These are your independent variables. We just need to understand that how regression can be applied in this particular case, right? So let's take some values a, b, and the values whatever y1. Let's take a1, b1, y1. If the values are a2, b2, then the value is y2. If the values are a3, b3, then the value is y3, etc. Right? So this is your training data. This is your training data. Now what will you do? Please try to understand. Okay. Similar concept, you just need to understand one thing, that you will identify the k nearest neighbor. Okay. Let me directly define the algorithm so that it will be easier. Now, just like classification problem, just like classification algorithm, identify the k nearest neighbor identify the k nearest neighbor. Please try to understand that if this is the scenario, that okay, these are your data points. So here we are not classifying this. Here we are not classifying this. Please try to understand that how regression will work. So this is the value x1, this is the value x2, right? So if I say that this point is a1 b1, if I say this point is a1 b1, so if this is our point which is selected, hello, if this is our point which is selected as our neighbor, if this is our point which is selected as our neighbor, then do we know that what will be the dependent variable with the when the value of x1 is a1 and the value of x2 is b1? Yes or no? Do we know if this is the point which is selected as our neighbor of our new point, then do we know the value of dependent variable y with respect to this input a1 comma b1? Yes or no? So let's assume that this is my new input. Let's assume that this is my new input, right? And the chosen points are a1 b1. This is the point. Let's assume this is a2 b2. Please, let's assume this is the point a3 b3. In sequence, these points are available. I'm just explaining. I'm just taking this point so that you can understand the concept, right? So the three neighbors which are closest to this new input are what? The three neighbors which are closest to this new input are a1 b1, a2 b2 and a3 b3. Let's assume that we are taking k equals to 3. Let's assume that we are using k equals to 3. Yes or no? So just like classification algorithm, identify the k nearest neighbor. Once you have identified the k nearest neighbor, do you know the value of dependent variable? This is a supervised learning. You are training the data. So in the training data, you already have the value of dependent variable. Yes or no? Please tell me that if these are the three neighbors to this new point, then we already know the value of y. We already know the value of y corresponding to this three neighbors of new data point. The value is y1 with respect to one neighbor. The value is y2 with respect to second neighbor. The value is y3 with respect to third neighbor. So what will be the value? Value of y will be nothing. Please try to understand. Value of y with respect to this new input, value of y with respect to this new input will be nothing but the mean of the values corresponding to those k neighbors. Means it will be y1 plus y2 plus y3. The value of k is 3. Therefore, whatever value is this, that will be the predicted value of y with respect to this input x comma y, with respect to, or let me call it L comma m. If I give a new point L comma m, then with respect to this new point L comma m, we will identify the three closest neighbor. With respect to those three closest neighbor, we will already know the value of dependent variable. We will just take the mean of the values of those mean of the values of the dependent variable corresponding to those k data points, and it will be the predicted value for the new data point. Clear? Clear how we can perform the regression using the k nearest neighbor. So there will be one extra step, that after identifying the k nearest neighbor, you will have to obtain the mean of the dependent value corresponding to those k nearest neighbors. Clear? Logic is clear, I believe. Logic is clear, I guess, right? So Let's try to learn this. I'm clumsy. The problem here is that I cannot add a new slide, otherwise I will not remove this. While preparing the slide, it did not occur to me that I might have to use some extra space. Okay, let's look at this. Just like classification algorithm, identify the k nearest neighbor. K nearest neighbor. Then what, sir? Obtain the mean corresponding obtain the, sir, what if these three neighbors are of different class? Fanto, this is not the classification problem. Please try to understand, when we are performing the regression, the classification is a different thing, regression is a different thing. If you are talking about this particular case, that what if we are taking the value of k as 3? What if we are taking the value of k as 3 and there are three classes C1, C2 and C3, and all these three members belongs to one in class C1, one is class C2, one in class C3, then ultimately we may increase or decrease the value of k. In that particular case, we may increase or decrease the value of k, and let's see, and can still classify the new input in one of the class. What the idea? Fanto, I believe that you are talking about classification problem, that let's assume that the value of k is 3 and all three neighbors are belonging to three different classes. All three members are belonging to three different classes. Then what will we do? In that particular case, you can either increase the value of k or you can decrease the value of k. So if you make k equals to 1, you will always be able to select a single point, and with respect to that single point you will always be able to decide that to which particular class this new input will belong to. Clear? To which particular class this new input will belong. So you can always do that. You just need to play with the value of k. I hope this is clear. But if it is regarding regression problem, then please try to understand, in regression there will be no class. So whatever those three neighbors are, those three neighbors will eventually have three different values corresponding to dependent variable. We just need to take the mean of those values and we will be able to predict the value of dependent variable corresponding to that new input. Clear? Clear. So, k nearest neighbor, take the values of dependent variable corresponding to those k nearest neighbor and then take the mean of those k values this mean will become the predicted value. This mean will become the predicted value of dependent variable with respect to new input x. Simple case. One extra thing which you need to perform after obtaining the k nearest neighbor is that obtain the mean of the dependent variable. Clear? Clear. No problem should be there. It is a very simple algorithm. The only thing is that when we were discussing the algorithm, we did not define that how this distance will be calculated. How this distance will be calculated. So find the distance of the new observation from all the data points. From the distance of the new observation from all the data points, and this is what is tricky. So please try to understand. If I define the Euclidean distance, so now is the case. Please try to understand. Please try to understand. Please try to understand. If we are calculating the distance only in one direction, let's assume that there is only one axis, that is axis x. If this value is x1, this value is x2, then what is the distance between these 2 points? What is the distance between these 2 points? Sir, in the Euclidean sense, if it is one dimensional, then the distance will be nothing but x1 minus x2. The distance will be nothing but x1 minus x2. Yes or no? Let's call it P. Let's call it Q. Distance between PQ. Distance between PQ is nothing, but please try to understand, x1 minus x2. Now the problem is this value may be positive, value may be negative. Therefore, you can do one thing, take the square of this and then take the under root. Take the square of this and then take the under, right? So this is the Euclidean distance, mode. You may think of it as a mode. Now, that's what I'm trying to define. You know this concept already with the help of mode. If it is a two-dimensional field, if this value is P, if this point is P, if this point is Q, the coordinate of P are x1, y1 and the coordinate of Q are x2, y2, then my question is, what will be the distance between PQ? What will be the distance between PQ? We all know this. Sir, when it is in 2 dimension, then we will take x1 minus x2 square plus y1 minus y2 square. That's what we do. x2 minus x1 whole square plus y2 minus y1 whole square. That's what we do, right? Yes or no? In a while, I am going to derive a new formula. That's what I am asking. If it is one dimensional, and this is the case. If it is two dimensional, it is the case. We also know the situation for three dimensional. We also know the situation with respect to three dimensional. We all can define this. I hope that you can visualize this concept that yes, this is a third dimension Z, right? So this is a dimension X, this is a dimension Y, this is a dimension Z. If I define a point, you cannot visualize this, but let's assume that this is a point in three-dimensional space, then it will be X1, Y1 and Z1. If there is another point in three-dimensional space, that is Q, and if this point is X2, Y2 and Z2, then how do we calculate? How do we calculate the distance? Sir, we calculate the distance of P and Q as what? Distance of P and Q will be x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. That's what we do. You all know these formulas, but the visualization is that if there is only one independent variable and one class, if there is only one independent variable and one class, then this formula will be used. If there are two independent variables, then the distance of point from a new point will be with respect to these 2 points, x and y. That what is the value of x, what is the value of y with respect to those 2 points. This is the value of x2, y2 of the training data. This is the value of x1, y1 with the new input data. So you will just check that with respect to this training data, how far is this particular new point is. So you will calculate the distance as x2 minus x1 whole square plus y2 minus y1 whole square. If there are 3 independent variables in the input, that means the dimension or the dimensionality of the input data is 3 dimension. So if it is a 3 dimension data, then how will you calculate the distance between 2 points? The distance between 2 points, sir, there will be 3 different dimensions of one data. There will be 3 different dimensions of one data, that how far it is from the new data in the x dimension, how far it is from the new data in the y dimension, how far it is from the new data in the z dimension. So each data point will have 3 dimensions. Each data point will have 3 dimensions. Now my question is, I hope this formula is clear to everybody. These 3 formulas are clear to everybody. These 3 formulas are clear to everybody. If I define that my input, or let's assume the database or the data set is of the particular form, what, that there is one variable x1, another variable x2, another variable x3, and so on. There are p variables x1, x2, x3 up to xp. x1, x2, x3 up to xp, and with respect to this p variables, there is one class. There is, where will I find the recorded lecture on YouTube of what, Vishal? Where will I find the recorded lecture on YouTube? All the previous lectures are available, right? So please try to understand. There will be different points. So this is one point. This is one point. One point will be represented. One point will be represented using p dimensions. One point will be represented using p dimensions. Are you getting this particular thing? One point will be represented using p dimensions. If you take a new point, or let me define it as that new point is having in x1 direction its value is a1, in x2 direction its value is a2, in x3 direction its value is a3, in xpth direction its value is ap, right? And with respect to that, the class is, let's assume whatever the class may be true. It may belong to true class. It may belong to true class or false class. Now if this new point is that value of x1 for new point is known, value of x2 for new point is known, value of x3 for new point is known. Similarly, value of xp for this new point is also known, and the values are, let's assume the value is new one. So this is L1 is the new value with respect to, L1 is the value with respect to field x1, L2 is the value with respect to field x2, L3 is the value with respect to field x3, and similarly LP is the value with respect to field xp. Now you are trying to predict the class. So first of all, you will have to identify the k nearest neighbor to this particular point. First of all, you will have to identify the k nearest neighbor to this particular point. How will you identify those? So first of all, what will be the distance? Let me call it this new point x. Let me call this new point x, and let me call this old point as whatever, capital A. Let me call this old point as capital A. If I ask you that what will be the distance between, if I ask you the distance between A and X will be what? If I ask you the distance between A and X will be what? Can you give me the answer? Can you give me the answer that what will be the distance between A and X? Sir, the distance between A and X is what? Sir, if there is only one dimension, then we'll check the difference between that dimension only. So it will be nothing. But what is the value in x1 direction? L1 minus E1 whole square plus L2 minus A2 whole square plus L3 minus A3 whole square and so on up to LP minus AP whole square. Clear? I hope you understand that this will be the formula. This will be the formula for distance between these 2 points A and X. If the data points are p-dimensional, we are not able to visualize the three-dimensional thing only. We are not able to visualize the three-dimensional thing only. But in the data science, the input may be p-dimensional. Any dimension will be there. I mean, the dimensions of the data point may be anything. Yes or no? Yes or no? So here, when I was trying to explain the algorithm and when I was saying that let's assume that these are the two dimensions. So this is the value of x1, this is the value of x2. Then we were checking that if the value of x1 is a and the value of x2 is b. If the value of x1 is a and the value of x2 is b, and if a new point comes in which the value of x1 is p and the value of x2 is q, then what is the difference between these two? What is the distance of these 2 points? What is the distance? Sir, the value in the x1 dimension is a for old point, the value in the x1 dimension is p for the new point, value in the x2 dimension is b for the old point, the value in the x2 dimension is q for the new point. Therefore, distance will be a minus p square plus b minus q square under root. Yes or no? Under root of a minus p square plus b minus q square. So please try to understand. Please try to understand that this dimensionality will eventually create problem when you are not trying to visualize this. So Euclidean distance between 2 points which are represented in a p-dimensional space can be given in this particular manner. Clear? Euclidean distance between 2 points A and X in p-dimensional space can be given using this formula. Is this okay? So, and another way you can define for any 2 points, the distance can be defined in what way? So, if there are 2 points x1 and if there are 2 points x and y, then you will define that with respect to variable x in dimension I, what is the current value? With respect to y, this x and y are not the planes. Please try to understand. When you look at this form, when you read this formula at some place, don't get confused. This is xi and this is yi. Then we are not talking about x dimension and y dimension. This I is the dimension. This I is representing the dimension. Right? So here we will define the summation of the square of the corresponding dimension. If there are p dimensions, then the value of I will vary from 1 to p. The value of I will vary from 1 to p. This is nothing but the distance between x and y. This is the distance between 2 points x, y. Got the idea? Got the idea? Please try to understand the logic. Don't mug the formulas. This is completely different. This is completely different. This x and y are representing 2 different things in this particular equation. In the above equation, x may be different. In the above equation, x may be different. But I'm just saying, if there are 2 random points x and y, then we need to subtract in the same dimension and we need to take the square of that. Clear? So if it's a p-dimensional data, then x1, what is, I mean, in the x1 in the dimension 1, what is the value of x? In the dimension 1, what is the value of y? So the value in the dimension 1 minus value in the dimension 1 corresponding to those 2 points, square of that will eventually give you the distance in that particular dimension. Clear? That's the Euclidean distance. This is Euclidean distance. If I try to define the Manhattan distance, then how do we define the Manhattan distance? Please look at this. If these are the 2 points, if it is dimension x1, if it is dimension x2, and there are 2 points, let's assume that this is point A comma B, this is point A comma B, and this is point L comma M, this is point L comma M. Then what is the Euclidean distance? Sir, the Euclidean distance is this. This is Euclidean distance. Sir, what is Manhattan distance? What is Manhattan distance? Manhattan distance is the summation of two things. Manhattan distance is the summation of two things. That in the x1 dimension, what is the distance? In the x2 dimension, what is the distance? So let me call it let's take some values. The variables are not sufficient. I don't know why. Variable, just choose a variable, let's assume that this value is x value, and let's choose that this value is y value, right? So what is the Euclidean distance? Sir, we already know the formula for Euclidean distance. The formula for Euclidean distance will be under root of, let me write in the same example, will be L minus a square L. So in x1 dimension the distance, in x1 dimension the displacement and its square, plus in x2 dimension the difference between the displacement, that is m minus b square, the summation of all the displacement, and then under root. If I talk about Manhattan distance, then how do we denote this Manhattan distance? We talk about Manhattan distance, then what is the distance in x1 dimension? Sir, in x1 dimension the distance is a minus L. Mod of a minus L is the distance in x1 dimension. This x, this is your x, this x is what? So this x, if you think of this, then what is this? So this value is actually x plus y. What will be y? Hello, please tell me, what will be the value of y? Sir, y will be nothing but mod of, in y, in the x2 dimension, what is the distance? So this value is m, here this value is b, it will be m minus b. It will be m minus b. Clear? So in p-dimensional plane, we have defined the distance in p-dimensional plane with respect to Euclidean distance. Let me define the distance in p-dimension for Manhattan. Manhattan distance between the data points x and y, p-dimensional, if there are p dimensions. If this distance is calculated in p-dimensional, then this will be what value? Sir, you don't need to take this under root. This under root is required because you are taking the square. This under root is required. This is a Pythagorean thing. So please try to understand. You can visualize the Pythagoras theorem in two-dimensional. Same Pythagoras theorem will hold true in any number of dimensions. Same Pythagoras theorem will hold true in any number of dimensions, but the only problem is that we are not able to visualize that. So what did we do? Sir, in a specific dimension, the distance between 2 points and the square of that and the summation of all those square, finally we are taking the under root. Here this concept is simple, that in what is the distance in x1 dimension plus what is the distance in x2 dimension, then what is the distance in x2 dimension, x3 dimension, etc. So summation of all. So you are summing up the distance in all the dimensions. So you are summing up with respect to that what is the distance in x dimension. So let's assume xi minus yi. So if there are 2 points x and y, if there are 2 points x and y, then x1 will represent the value in dimension 1, y1 will represent the value in dimension 1 for the points x and y respectively. For the points x and y respectively. So this summation will be your Manhattan distance. This summation will be your Manhattan distance. Please tell me if you guys are having any problem in understanding this concept of Euclidean and Manhattan distance. Whenever you see a problem of classification, when you see x1, x2 and you think that there are some data points, if you think that there are some data points, then it does not mean that we are trying to predict the value on the y plane. No, this is a given data point, this is also a given data point. We are just trying to predict that to which class this new element will belong to. There is one doubt in Euclidean distance. What, Manjushri? What doubt? What doubt? Please try to understand this x and y are the data points. When I say I, this I is representing the dimension. This I is representing the dimension. What doubt is troubling you? You can ask me. This is the distance between x and y, obviously in p-dimensional plane. In p-dimension space. Don't get confused. So the algorithm is damn easy. The algorithm is damn easy, that you just need to find the distance of the new point with all the data points. You just need to find the distance of this new point with all the data points. Now, sir, which distance? Euclidean distance or Manhattan distance? It will be given in the problem. Which distance? Euclidean distance or Manhattan distance? It will be given in the problem. Clear? So that's not a problem, but once you know how to calculate the Euclidean distance, how to calculate the Manhattan distance, then only you will be able to identify the distance of this new point from all other data points. Clear? After getting the distance, you just need to sort them. Then you need to select k nearest neighbors. Then you just need to check that maximum, in which particular class the maximum out of those k neighbors are belonging. Your new input will also belong to the same class. If you are talking about regression, then please select k neighbors. Just take that, check that what is the value of dependent variable corresponding to those k nearest neighbor. Just take the mean of those k values and this will become a new predicted, this will become the predicted value for the new input. A point, Manjushri, when you say a point, where is a point? This is point A. This is your point A you are talking about. So this is point A. This is some point X. Okay, I guess that why you guys are confused are because of this different nomenclatures. And see, please try to understand. I was not trying to give this formula, but it's okay. Let's try to understand that these are the p dimensions. These are the p dimensions. Don't think of them as x1, x2, x3, x4 up to xp. Right? I just pass this information in a new name. Let's assume that this is the independent variable v1, this is the independent variable v2, this is the independent variable v3, this is the independent variable vp, this is the independent variable v1, this is the independent variable v2, this is the independent variable v3. Similarly, this is the value of independent variable vp. Clear? What the idea? Now let's assume that this, please try to understand, don't think of this in this particular format, but let's try to understand that this is your new point x and you already have a point y. You already have a point y, right? Or this is your point y which is already there. Now let's assume that with respect to point y, the value of variable v1 is y1. The value of variable, these are value, right? So with respect to variable v1, with respect to variable v1, the value of point y is y1. With respect to variable v2, the value of point y is y2. With respect to variable v3, the value of point y is v3. Similarly, with respect to variable vp, the value of point y is vp. Similarly, with respect to point x, the value of with respect to point x, the value of variable v1 is, let's assume, x1. With respect to variable x, with respect to point x, the value of variable v2 is x2. With respect to variable x, the value with respect to point x, the value of variable v3 is x3, and so on. With respect to point x, the value of variable vp is xp. Sir, good evening, Vishal sir. Thank you, Satya sir. Thank you. Right? So now when we are calculating the distance, how do we calculate the distance? Sir, in dimension 1, which is representing the variable 1. So in dimension 1, what is the distance between x and y? Sir, x1 minus y1, right? So x1 minus y1 whole square. In dimension 2, what is the distance? Sir, x2 minus y2, therefore plus x2 minus y2 whole square. In dimension 3, what is the distance? Sir, x3 minus y3, therefore x3 minus y3 whole square. So if we are defining in p-dimensional space, Manjushri, I hope now it is clear that if I am trying to define in the p-dimensional space, then I am simply saying that with respect to input x in dimension 1, what is the value? With respect to input y, with respect to point y, with respect to point x, what is the value in dimension 1? With respect to point y, what is the value in dimension 1? With respect to point x, what is the value in dimension 2? With respect to point y, what is the value in dimension 2? With respect to point x, what is the value in dimension 3? With respect to point y, what is the value in dimension 3? So there may be any dimensions, any number of dimensions. There may be any number of dimensions. So don't worry, because of this L1 minus A1 square, L2 minus A2 square, L3 minus A3 square, I just wanted to give you the intuition that what we are calculating is the distance in a individual dimension square plus the distance in another direction square plus a distance in third dimension square plus distance in fourth dimension square, etc. And finally take the under root, you will get the Euclidean distance between those 2 points. You will get the Euclidean distance between those 2 points. So if I define that this is with respect to point y, this is with respect to point x, then the distance between x and y can be given by this. This is the idea. This is between a and x. With respect to a, I assume the point as a1, a2, a3. With respect to x, my bad, I assume the points as L1, L2, L3. Therefore, you got confused. So, sorry. So here, I hope this is okay. That in x dimension, this is the value. In y dimension, this is the distance. So, in dimension 1, with respect to point x, the value will be x1. In dimension 1, with respect to point y, the value will be y1. So x1 minus y1 will be distance in dimension 1. x2 minus y2 will be distance in dimension 2. So just sum up the modulus of all those distances, you will get the Manhattan distance. You will get the Manhattan distance. So that's the simple logic. So the canonical algorithm is damn easy. You just need to calculate these distances. Either it will be Euclidean or it will be Manhattan. Now comes the k-value selection. Please try to understand. It's too much time, but please try to understand. If the k-value is too small, then it may not produce accurate result. If the k-value is too large, then also it may not produce accurate result. So, in order to identify the correct value of k, you just need to play with different values of k, and then you need to check that which particular k value is producing the best result. Now, let's try to understand that if I give you an example that these are the data points. This is what I am trying to obtain. This is please try to understand this, that if this is a new input, if this is a new input and if we are trying to classify this, so please try to understand, if we take the value as 1, if we take the k value as 1, then this will eventually belong to this yellow color portion. Yes, if we take the k value as 3, if we take the k value as 3, not a good circle. If we take the k value as 3, then this point will start belonging to red color class. If we take the k value as 1, it may belong to blue color class. If we take the k value as 3, it will start belonging to red color class. Again, if I increase the value by 1, then it will start belonging to some other class. If I again increase the value of k, it will start belonging to some other class. So, which k value will give the perfect result? Which k value will give the perfect result? It is a problem of discussion, right? So no perfect algorithm is available which can be used to identify the k value. Therefore, the k value should not be too small, the k value should not be too large, right? K value should be moderate. Generally, we take the values of k as 5, 7, 9, etc. We do not take the values of k as a very large value or very small value. Clear? So k value selection is very important, but in order to select the k value, you can run the algorithm. You can run the algorithm with different values of k, and you can check that which one is producing the most accurate result. Yes or no? In order to obtain a good k value, what you can do is you can run the algorithm with different values of k, and whichever k value is producing the best result, you can use that particular k value in that specific case. You can use that particular k value in that specific case. So I hope everybody has understood the concept of k nearest neighbor algorithm. It can be used for classification. Concept will be different. For regression, you will have to take the mean of the dependent value of the dependent variable corresponding to those k nearest neighbors. This is it. Clear? Euclidean distance and Manhattan distance may give you problem. Therefore, I have explained that what do I mean by Euclidean distance and what do I mean by Manhattan distance. This is it. Thank you very much for joining this session. You guys can join this Telegram group. If you guys have any doubt related to GATE CS paper or GATE DA paper, then you guys can definitely ask your doubts and I'll be happy to answer. That will be all. Thank you very much for, this slide is missing. If you like the video, then please hit the like button. अब देखो वापस से बाद में आया है, कर देना. So if you like the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon so that you will get the notification about such good videos. That will be all. Thank you very much. Good night. Take care. Sweet dreams. Keep learning.